Hello everyone. Today we are solving the plus minus problem by HackerRank. The link to this problem will be in the description. It says, given an array of integers, calculate the ratios of its elements that are positive, negative, and 0. Print the decimal value of each fraction on a new line with 6 places after the decimal. So the constraints for this problem is that the size of the array will be greater than 0 and can be less than or equal to 100. And the elements in the array, the integers in the array, can be equal to negative 100 and can be any value from that all the way to positive 100. So this is a review of the problem. As we said, we're calculating the ratio of the elements that are positive, negative, and 0. Then we're printing the decimal value of each fraction on a new line with 6 decimal places. Let's go through an overview of the solution. So step 1, we had to count the total of negative, positive, and 0 numbers. Step 2, we get the ratio of the negative, positive, and 0 numbers in the array. And the ratio simply means the count of each thing, so count of the negative over the size of the array, and then count of the positive over the size of the array, and count of the zeros over the size of the array. And we do not need to calculate the size of the array because that value is stored with the array. Step 3, we print the ratios with 6 decimal places, each on its own line. So we're going to do an example, and after this example, we'll dive into the code. So given this as our array, how do we solve the problem? Well, the first step is to get the counts. So negative 4, right, that's a negative count, so we increment that. 3 is a positive count, increment positive. Negative 9, negative count, so we increment that. 0, so we increment the 0 count. Then 4, increment the positive count. 1, increment the positive count again. Now that we have the counts of all the elements in the array, we can move on to the next step, getting the ratios. So the ratio, we need the size of the array, which is going to be stored in programming. The size of the array is stored with the array itself. So we'll see that when we do the code. So we have the size and we have the counts. So we do get the negative ratio by the counts divided by the size. And the 0 ratio is the counts divided by the size. Positive ratio is our count divided by the size. And when we calculate these, we get decimal notations. None of these are formatted to 6 decimal places. So that is our final step. Now, formatting is going to be specific to your programming language. We're going to be coding in Java, so it might be a little bit different for you if you're not using Java. I'd like you to take a moment, pause the video, try to solve this on your own, and then we'll solve it together. Okay, so normally we would solve the problem here in HackerRank, where it says write your code here. But I can't resize this window, it's a little small, so I'm going to solve it in my own IDE, and after I've written the code, I'll go ahead and paste it into here so that we could see if it runs correctly and solves all of the solutions. So our first step, we need to get the counts. So we want the positive count, and we're going to initialize that with 0. And we're going to do the same for the negative counts and the 0 counts. And now that we have a place to store our counts, we're going to loop through the array to get the counts. So we're going to say for int I being our index of the array, and while our index, is less than the size of the array, we're going to increment I for each loop through our array. So we get our current number in the array, equals to array.get at our index. And now that we have a current number in the array, we can check, is that current number greater than 0? If it's greater than 0, then we know it's positive. and we increment our positive count. Otherwise, else if our current number is less than 0, then we know if it's less than 0, it's negative, so we increment our negative count. Else, so if it's not positive, it's not negative, then it has to be 0, so we increment our 0 count. Now that we have our counts, we can move on to the second step, which is getting our ratios. So the ratios will need our denominator, right? And the denominator is the array size. And now that we have our counts and the denominator, we can get our ratios. So it's going to be our positive ratio will be equal to our positive counts divided by our denominator. And our negative ratio, same thing, negative counts divided by our denominator. And lastly, our 0 ratio is our 0 counts divided by our denominator. So I want to take a moment to explain why I'm using int here and then double here. So int is for integer, and that's for whole numbers such as -1, 0, 1, 2, etc. Double is for decimals, so 1.2, 10.561, etc. And so since we're getting counts here, we only need integer values, and since we're getting ratios here, we need decimal values, and that's why we're using double here and integer here. So now that we have our ratios, the last step is to print out the ratios each on their own line. So system.out.println is how you print in Java. And it did say we also have to format it to 6 decimal places. So in Java, you could format with this notation here. So this indicates how many decimal places you'd like to format to. So we could say 0 decimal places, 1 decimal place, but in this case we want 6 decimal places. So I'll go ahead and pass the positive ratio, and I will copy and paste this so that we could use it for our negative ratio and our 0 ratio. And our 0 ratio. So that concludes our solution. Let's go ahead and paste this into HackerRank and confirm that it runs successfully. So submit our code, and all of our test case pass. So I want you to take a moment and try to determine what is the time complexity and space complexity of this code. If you're not sure what that means, I have a link in the description called Big O notation. And after you've thought about that, we'll go ahead and figure that out together. So just pause this video, take a moment. Okay, so let's talk about time complexity. So time complexity means how long does a piece of code take to run relative to the given input. So our given input is this array, and we want to know, does the time it takes to run this method change based off of what our array is? And if so, what does that relationship look like? So these 3 lines of code and these lines of code here are constant. Regardless of the size of our array, it will take the same amount of time to run these 3 lines of code and these lines of code here. However, this for loop does change. So if this array is of size 1, then this executes 1 time. But if this array is 1,000,000, then this executes 1,000,000 times, which would take longer to execute the method. So the time complexity here is linear. It's O of n. N meaning the size of the array, right? Equaling the size of the array. So if the array size is 1, this executes 1 time. If it's 1,000,000, it executes 1,000,000 times, thus making the time complexity linear. And yeah, so that's our time complexity. So going now to our space complexity. Space complexity asks the same question. is there a relationship between our input, get right here, and how much space is being used in memory? So the things that we're using in memory, right, is our integer values and our double values. But this is constant. If our array size is 1, or if our array size is 1,000,000, we're using the same number of variables in memory. So to represent constant, we say O of 1. And that concludes our solution for this HackerRank problem. If you guys have any questions or any feedback on what you liked or didn't like about this video, please let me know. Thank you.